This is part 3 of your analytical chemistry tutorial. In the last tutorial, we did carbon dioxide and sulfur dioxide, and in this one, we're going to move on to chlorine, nitric acid, hydrogen chloride, and hopefully hydrogen sulfide as well. Okay, so starting with chlorine, I'm going to erase this now. So, chlorine was again put under acidic gases, if you remember. Um, and chlorine too has a distinct color. It's one of the only gases actually that has a distinct color. Okay, so to start off, here, so Cl2. Actually, I'm gonna do it with a greenish color, and you'll get to know why later. It's more like yellow. Okay, Cl2. The color, well, yeah, now you get to know why I did it with this color. It's this greenish yellow color. Odor, well, in your books it'll probably say choking odor. You should just learn it as that, but mm, you you really won't be asked this because choking is not really a good definition. It could mean different things to everybody else. So just learn that it is definitely not odorless. It has an odor. You can learn one adjective like choking, but that's about it. Chemical properties. The main one is that it turns starch iodide paper blue black. So starch iodide paper, it's turned blue black. So I'm just gonna use a dark blue here. So it's turned blue black. And the reason for this is because it's electronegative. It's electronegative. Now you can try and figure out what that has to do with this, but I really don't think it's meant to be taught at this level. So I think you should just leave it at this for now. And another property is and usually it's grouped under acidic acids. Not sorry, not acids, acidic gases. So you can remember it as acidic. And also it bleaches litmus. It bleaches litmus. I really don't think you need to know what that process is like. So again, at this level, just leave it at this. I'm sure if you want to read more about it, you can go on the net. But for now, you just need to know this. Um, that's it for chlorine. It's pretty short, and the good thing about it is that uh, you can figure out that it's chlorine just by looking at the color. Greenish yellow, no other gas, at least in your syllabus, has that color. So it's unique in that way. And also starch iodide paper. Okay, the next gas is nitric acid. I'm gonna take a brighter color here. Nitric acid. So HNO3. Color is odorless. Sorry, I don't know why I say odorless, but sorry, it's colorless. The odor, it's given in some books as irritating, but again, same thing. It's a very vague adjective, so just learn it as that it does have an odor. It is an irritating, choking odor, but I don't think you should go more than that. Just leave it here again. It is acidic because it's nitric acid, of course. This is nitric acid. So as you would be familiar with it by now, um, so right, chemical properties. Since it's acidic, it turns blue litmus, moist blue litmus, remember that. It turns it to red. Okay, and also HNO3. Another special feature of this is that it turns potassium iodide paper brown. So potassium iodide paper, you may have seen it in the lab. It's also called Ki paper. It looks something like this. It's in strips like this, and when you expose it to nitric acid, I'm just going to label this as Ki paper, potassium iodide, and well, actually it's pretty brown already, but it's just going to turn even more brown, say a darker shade like this. Oops. Something like this. So that's it there. This is all for HNO3. uh, the only unique things about this is it is not odorless, and the Ki paper bit, so remember this for sure. Now the next one, and we're going pretty quick here, but there's not much to know here, is HCl, hydrochloric acid is HCl, which is dissolved in water, and here it's just hydrogen chloride, remember that difference. So HCl, if we just continue this column here, color, it is colorless, and keep in mind that this is a gas that we're talking about. We're not talking about HCl as in the acid. So colorless. Odor, yet again irritating odor, so same thing, just learn it like that. Just gonna write IRR. And under chemical properties, uh, same thing, turns moist blue litmus into red. So blue litmus here. Since HCl is acidic, as usual it'll turn red over here. Sorry, it turns red here. Okay, the other chemical property of hydrogen chloride I told you earlier as well. um, when you have NH4OH solution, NH4OH, and you you take you dip a rod into it so that it gets submerged in the solution, and then say there's HCl all around over here, and you bring this rod here, what you'll see is very very dense white fumes. I'm just gonna do it in white, so you'll see white fumes coming out like this. The reason for that I'm gonna give you now. The reaction, you can guess the reactants, HCl and NH4OH. What they form is ammonium chloride, which is NH4Cl. The other products don't matter really, this is the one you need to focus on. And this takes up the form of dense white fumes. That's how it literally looks like. It's all like this. So this is actually what you see when we say dense white fumes. And this again, this is the unique thing about HCl, the unique chemical property which could help you say that this is HCl. And that's it for HCl. And now I'm gonna just quickly move on to hydrogen sulfide. So I'm just going to erase this. Okay, hydrogen sulfide, we've already done another compound, another gas which has sulfur in it. That was of course SO2. So okay, I'm going to write it in a sort of yellow, because as I said earlier, I associate all sulfur compounds with yellow for some reason. Okay, color, despite the yellow, it's colorless, sadly. um, I'm just gonna write that all at once. Its odor comes here, and chemical properties come here. Now it's colorless, so I'm putting this to show that. Odor. Now I really don't know how to draw this, but I'm gonna tell you before so that you have some idea of what I'm talking about. uh, Odor is rotten eggs, so I guess I'll just draw an egg over here. Now this is H2S's unique property. Whenever they'll ask you a question, in all probability they're going to ask you, give the gas that smells like rotten eggs. And yeah, you can just make out at the first go that this can't be any other gas. It has to be H2S. So I don't know if you understand from this figure that it's rotten, but honestly I did pretty well. Okay, now the chemical properties, acidic again. You can make that out because of the H2S. You see the H over here. Of course you have H2SO4 as well, which is sort of related. So it is indeed acidic gas. So as you would be very familiar with this now, it will turn moist blue litmus paper to red. Okay, and the other feature of H2S, another thing that it does is turns lead acetate paper silvery black. Lead acetate, the formula is actually pretty long. You'll do it under hydrocarbons, but for now I'm just going to write it down here. Lead acetate, it it is turned a silvery black, so I'll do it in a silvery black shade as well. Okay, and that's all there is for these four, sorry, not two. And I think I'm gonna finish up NO2 and ammonia as well quickly right before I leave you and come back with the next part of the chapter. So NO2 I'm going to do in brown. The reason you can guess. NO2 color, it is reddish brown. So a reddish brown, you could say it's something like this. Now the odor, in your books it'll probably be written something like irritating odor again, or pungent. I think pungent would be a better word here. It's pungent. If you want, you could learn it as irritating. But again, the major point is that it is not odorless. It does have a distinct odor. It is acidic as well. So again, blue litmus turns to red. always in a question when you're told to identify a gas and you're given parameters like turns blue, litmus red, what you should do is just visualize and just think about what property does that show. So from blue to red you could figure out it's acidic, and then you could slowly eliminate all the other options. All the basic and neutral gases you could eliminate, but more often than not there'll be one very distinct property which only that gas will have. So that's the key. You just need to know the very distinct properties. And for NO2, the distinct property is this: it turns potassium iodide paper, which is Ki paper, it turns Ki paper brown. So you can see that not only is it brown, but it also turns Ki paper brown. So you could draw it something like this. It turns Ki paper brown, and I'm just drawing all these little illustrations side by side because if you want to revise this concept, all these things right before your exam, if you want to revise these things right before your exams or something, this is just a quick tutorial, and all these drawings really just help you to connect things like this. When you see NO2 over here, hopefully you'll remember this drawing here and this one here, so it'll all come back to you pretty quickly. H2S, I mean, this is as unique as it gets, so you should remember this. Now I'm gonna go on to the last gas, which is the only basic gas that you'll be doing. So, and that is of course ammonia. Now ammonia, okay, so ammonia I am going to do with, I don't know, blue maybe, NH3. Color, not surprisingly, it's colorless. It's colorless. Odor, it has a pungent and irritating odor, just like NO2 that we just read. Pungent, just writing pun, and irritating, ir. Okay, but as I said before as well, um, this is a very vague description, but just learn it just in case. Uh, it is basic, the only basic gas, and so as I told you right in the beginning, basic gases will turn red litmus blue, unlike acidic, which will do the other way around. So red, and it is turned to blue. Okay, and the distinct property for NH3 is actually the reverse of that of HCl. So in HCl what we had was that if you have HCl here, you have NH4OH here. So we had NH4OH. So we had NH4OH over here, and when you dip a rod into this, bring it here, you see dense white fumes, which is NH4Cl, as we said earlier. Now in the case of NH3, what happens is that again dense white fumes are produced, but this is when you have an HCl solution here. Yet again dip a rod and bring it near the ammonia. Now you can see it's pretty clear that NH3 and HCl will combine to give NH4Cl, which will give the same dense white fumes as we had before. The only difference between this is that over here, in the case of HCl, we had more than one product. We didn't only have NH4Cl, but we had another compound, or another compound coming out as well, which was water, but we don't need to go into that. And over here it is just these two combining to give NH4Cl and nothing else. So that's about it. Just to summarize, all of the gases have usually one, some have two distinct properties, and those are the ones that you really need to do well. And stuff like acidic, basic, those things you have to know anyway. So in the next part I'll be doing detection of cations and thereafter anions as well. So but that's it for this video.